We'll proceed in summation to integral. Okay, very difficult and mind-blowing, head-hitting discussion that we have initiated. Summation to integral. Summation to integral is a discussion that would lead anyone to proceed from the statistical mathematics to calculus. Okay, we have seen that there are two ways to enter into integral calculus. One is multiplication. If you are multiplying two items and one item is dependent upon other item, being other item as independent variable, then we can transform into integral calculus. And this is the form generally it is being used in the normal mathematics. Like I was seeing this, like I have given example LCR circuit. L is for inductance, C for capacitance, and I is LCR, R is for resistance. If I have a DC voltage source or AC voltage source, consider DC voltage source. DC voltage source, it is connected to a resistance, then capacitance, then inductance in series, and back it is connected to the battery source. What is the equation? Consider there is a switch and I switch it on. If I switch it on, then what is the equation of current in the circuit as function of time? Okay. If it is only resistance, the current is constant always. That is voltage by resistance. Resistance. If it is capacitance, then voltage across the plate of capacitance equal to 1 by C into charge. If I divide C by T, how much voltage is accumulating per unit of time? V by T equal to 1 by C into Q by T. Now voltage is dependent upon time. At different time, the change in voltage what we see is different. What I mean is that at the beginning, if someone sees 1 unit of time span, and then how many unit of voltage is growing on the plate of capacitor after time t. Again, if he sees 1 unit of time span, and then he see how many voltage is getting added at in 1 unit time span, that was calculated at the beginning and now it is different. Means depending upon the time, depending upon the time per unit time, how much is voltage getting accumulated on the or charge on the plate of capacitor is different. So V by T, how much voltage per unit time, actually V by T changes as per the time. Every time per unit time, how much voltage is accumulated there, it is different. So V by T is fit candidate to say dV by dt. dV by dt equal to 1 by C dq by dt. dq by dt is current. So current equal to C into V. C into dV by dt means if I have only capacitance connected across battery, then current at any moment is C into how much voltage is changing per unit change in the time. So it is not constant. But if I have only resistance, then how much current is per unit time, that is constant voltage by R. Here it is current is C into dV by dt. If I take inductance, if I connect only the inductor across the voltage source, then voltage, actually I was thinking it is 1 by L, it is L I believe. Voltage at the inductor, voltage across the inductor is equal to inductance of the inductor into di by dt, change in the current per unit time, or I by T. Okay, I by T also someone can say. Okay, change in the current per unit time, this will become a differential calculus. So I mean it is dependent upon the time di by I by T. So it will become di by dt. So in that fashion, the current, any moment the current is 1 by L into V dt integration. Di by dt equal to 1 by L into voltage, means I equal to integration 1 by L V dt. How much is the voltage? Voltage multiplied by the time. V dt means voltage multiplied by the time. So everywhere we are seeing things are different. But what we see in the LCR circuit is division we transform into differentiation, and multiplication like V into T. Actually, it should be voltage across inductor is voltage equal to L into I by T. Current at any moment would be 1 by L voltage into time. More we span the time, then V into T will grow. Okay, and current is dependent upon it. If I have V into T and voltage is dependent upon time, every time, every moment of time, if I see, every moment of the time, if I see V into T, I, I'm sorry, I would rephrase this, voltage into time, where voltage is function over time means at different time voltage is different. Voltage is function over time means it is depend upon time. If it is V into T and voltage is function over time ft into T, it will become V dt means current at any moment is integration 1 by L V dt means multiplication we transform into integration. Anyway, this is one form that we have seen, but in a statistics kind of environment where we have tons of probability and this and that, then typically we see the repeated summation kind of thing. Repeated summation in a way that we sum item to an extent and then we try to find out the summation. Okay, what is the simple example of repeated summation that we will pursue now? What is the simple example of repeated addition? But generally in statistics, it is used in terms of probability. Okay, probability in the sense that if I have a random variable means like I have two dice which is 1 to 6 and another dice 1 to 6. I have two dice now. Okay, now in that fashion, if I throw two dice together, how many times, what is the probability? Means how many times I will see sum as 6. Makes sense? How many times I will see sum as 6. This is what is the, this is not an event. This is called random variable. How many times 6 is coming? Okay, what is the probability that addition of both dice will be 6? This is called event. I have an event where the addition of both dice will be 6. Okay, I have a random variable which will say how many, which will say that, I mean, sorry, how, okay, uh, how many times it is 6. Okay, how many times it is 6? I believe I am messing up something. Okay, if I say how many times it will be addition is 6, this is an event. How many times addition is 6? Okay, if I add, if I add and whatever we get, this is a random number. Consider if I add and whatever we get, this is a random number. Okay, random number. In that random number, if I get 6, then this is an event. Okay, now I'll draw a chart, x-axis and probability. Now addition of both is 2, because minimum it will be 2 only. Addition of both is 2. What is the probability? Now there are 36 outcomes are there in sample of space. There are 36 outcomes are there. Now the first outcome I am interested that what is the addition of two dice number, that is the random number. This is what we are interested in. If it is 2, then it must be 1 on one side and 1 on one side. It cannot be 2 and 0. There is no 0 here. 2, then probability of getting 2 addition is 1 by 36. Now I draw, this is x-axis, this is y-axis, and now probability of getting addition 2 is 1 by 36. What is probability of getting addition as 3? 3. Then first will be 1 and another will be 2, or first will be 2, another will be 1. That will come as 1 by 18. What is probability that it will be 4? If it is 4, first is 1 another is 3, first is 3, another is 1, or first is 2, another is 2, that is also will give the 4. Means it is 1 by 12. Like that, I draw the probability. Okay, now these are called, now we have so many bars now. At summation 2 to summation, I believe 12. 12 is the maximum possible summation. 2 to summation, what is the probability bar? So these are typically comes under repeated addition. If I add all the bars, then the net it will become 1. That is guaranteed. Now these bar have discrete value. That is, one is 1 by 36, one is 1 by 18, one is 1 by 12. If I say addition should be 6, then there are many ways. 1 and 5, 1 and 5, 5 and 1. Two outcome is possible, 6. 2 and 4, 4 and 2. Now 4 outcome is possible. 3 and 3, 5 outcome is possible. I think so. So it will be 5 by 36. Like that, this is so many. We have 2 to 12. I believe it will come as 11. 11 bars are there. Okay, if these are called discrete bar. There are individual bar. Okay, if I make repeated addition, now I can say summation of I equal to 2 to 12. I equal to 2 to 12 fx, where x is in the ith section. Make sense? Like x is 2, x is 3, x is 4, x is 12, fx. Function over that. Okay, this is one arena where we have discrete value against the different slice in x-axis. Can I convert this discrete value fx into a continuous range? Not for why you want continue? I want continuous range. Why you want? I want continuous range. Okay, but it cannot be continuous. X equal to 2, x equal to 3, x equal to 4, x equal to 5, x equal to 2. 12. It cannot be x equal to 2.2. But still, I want the continuous. Now, okay, what is your summation now? Summation is I equal to 1 to I equal to 1 to n, that is 12, and fxi. This is the summation. Can I convert into a continuous line where at any point I can see the probability or something like that? Okay, can I see in that fashion fx will change into gx? What is the nature of continuous and what is nature of discrete? If it is a discrete, then summation of all the bars what we take, it must be summed into 1. That is for sure. If I take continuous line as probability, this is called density function. The bar what we are seeing in discrete manner, it is called mass function, probability mass function. The prerequisite is probability mass function. If I add all, then it should become 1. Okay, but okay, if I take a probability density function as a continuous function, consider that is gx, then integration of gx means if I take area of gx, I believe it is all right. Consider this is x-axis and this is origin. We start from 2 and end up in 12. On top of it, here we have so many bars, 11 bars are there, and they have peak value. I'm not going to connect all the peak value and say this is your continuous line because requirement is different. If I have continuous line, then also it talks about the probability only. But continuous line if I have, then multiplication of this continuous line with this width, I mean I'm talking about the area underneath it, it should be 1. If I do integration from here to here, area means integration. Area means integration. If I have another function as gx that represents the fx what we talked about, then gx dx from 2 to 12 should be 1. Now see the difference. If I take discrete, the summation of all discrete should be 1. But if I take continuous, the integration of continuous, if g fx is fx representation is continuous is gx. If fx works in discrete manner also and fx works in continuous manner also, then fx dx x equal to 0, x equal to 2 to 12 should be 1, and it will be 1 here. Why? Because 2 to 12, we are sampling at 1 gap. If I'm sampling anything in at one distance, then it will behave like a continuous function also. But if we are sampling other than 111, then it will not behave like a continuous function, and I have to find another gx that will represent fx in continuous manner, and gx dx from x equal to 2 to 12 should be 1. Why this fx can be represented as in continuous manner also? Because I can rewrite a summation of I equal to 1, I equal to 2 to 12 fxi as fxi into delta xi, where delta xi is one fixed. Because with every bar, if I have bars, with between every bar there is one gap, 2, 3, 4, 5, there is one gap. So this gap, if I multiply this bar with this gap, one gap, it gives me the area of this slice. If I add all the area of the slice, then it gives the net area. Means this fx can be represented in continuous manner also, because continuous manner underneath area is what we want. So this case it can be done in that fashion. But anyway, we have taken another example also. What example we have taken? Like there is a stick. Many times I have described it. There is a stick of length. Consider there is a stick of length 10. There is a stick. Oh, where is a stick? There is no stick. Everything is gone. Nothing is here. Okay, consider that I have a stick now, and a stick is of length 10. Stick is of length 10, and I'm going to break it at any moment, any place. Now, how many times I can break it? Infinite number of places I can break it. Now, if I say what is the probability that I break at a particular time, at a particular point, what is the probability? We cannot say what is the probability. Okay, it is possible only when consider that I break this stick, 10 meter long stick into n different sections, n number of different sections, where n can be 100, 1000, whatever it is. Now, if I'm going to hit, I close my eyes and I go and hit at one place and see that it is which n. From n is 1, 2, 3, 4, 5, 6, ith, then n. This 10-meter stick I divided into n section. If I close my eye and hit at any n, at any place, it will belong to a particular number where the number starts from 1 to 3 and goes till n. N sections are there. What is the probability that I hit at a particular section? 1 by n, because there are n number of sections. Okay, now in that fashion, if I see the distance from here, then if I hit at any ith section, then length from here is I by n into 10. The net is 10. And that is more or less, it will not be integer at all. If n tends to infinity, then it will be very fine number. I'll get I by n into 10. But if I take the probability, if I draw the probability the way I drew that, these are not available in any of the book. That is the problem. Okay, if I take the probability, the way I computed probability for the dice, what is probability? It will be 2, 3, 4, 5. Similarly, what is the probability that it is at I by n into 10? Consider I is 30. I divided into 100 parts. 30 by 100 into 10, 30 by 10, it is at distance 3 from here. Oh, nice, 3. Consider that I is 38, then it will be 3.8. I is 43, then it is 4.3. If I divide into 1000 section and if the I is 1000 section, I is 43, then length will be 0.43. Okay, means there are so many and they are not integer space. They are not 111 space anyway. Now, if I calculate the net probability, if I add all the bars, the net probability must be 1. It will be. If it is 1 by n, if I add 1 by n bars and everyone has height 1 by n, net probability will be 1 only. It's satisfied. What is your fx? Fx, the height. Fx is 1 by n. Can I write like summation of I equal to 1 to n fxi equal to integration sign 0 to 10, because x is 0 to not I, x is 0 to 10 fx dx. Not possible, they are not same. Okay, when they are same only when I divide this 0 to 10 into 10 different parts. Please watch our previous video. Okay, if I divide into n different part where n is 10, means every space between every one is 1. In that fashion, summation of I equal to 1 to n fx at x equal to I by n, I by n into 10, whatever it is. This will be exactly equal to summation integration sin x equal to 0 to alpha, x equal to 0 to 10 fx dx. But if I divide this into n numerous part where each part is not spaced by 1, then summation I equal to 1 to an fxi will not be same as integration x equal to 0 to 10 fx dx. In that sense, fx dx, and fx in integration will be another function called gx. Then it's possible. I mean, the gx need another gx will come, that will be a continuous function, and continuous function will gx will, if I multiply gx with the gx of, I'm sorry, what I'm trying to say is that what is integration? If I say integration of x equal to 0 to 10 gx dx, it is same as summation sign I equal to 0 to 10 gxi delta xi, where delta xi is 1, or summation of I equal to 1 to n is anything, gxi ith point, what is gx, into delta xi, where delta x is the width of the each sampling. Okay, means if I multiply our bar height with the width, then it gives the area subsection. If I add all your area subsection, then I can simulate as a continuous line integration, that is the total area. Anyway, these things we have seen in detail in the past. We are in phase of calculating the, so what is the fundamental now? Fundamental of the summation is I cut whatever I want, the problem. Main aim of mathematics is to solve the problem. Main aim of mathematics is to solve the problem. Main aim of mathematics is not to bring calculus, vector and statistics and probability, to bring so many high-fi things or very great things and then solve the problem. Making people, I've seen it. I have seen it. If you see the C++ and these programming, unnecessarily people bring something like iterator, and then something like template, and then so many things. And that's why Python came into picture at the end, because people were unnecessarily, they were making it very complex. Then at the end, Python came and it has all everything. 99% of what C++ generally people write in the program, 99% of the complexity is hidden inside the Python only. You do not need to worry about. Everything is there. By default, everything is there. Reference counting to iterator to everything is by default there. That you can polymorphism, everything is by default there. And it is implemented by people who are very smart. So that is the idea. Otherwise, people they make nonsense unnecessary. So here also, if you are solving any problem, people introduce complexity unnecessary. Let's take delta x and this and that, and then just add this and then dual integration. And people do not understand, because main aim is to solve the problem. Main is not to see your smartness, how smart you are. Anyway, so the main idea of solving problem, when we see, then it is to solve the problem. One way to solve the problem is to break your problem domain into many parts and then solve it. Okay, the like we were in phase of calculating the surface area of the circle, and if this is x-axis and this is y-axis, and consider this is This is x-axis and this is y-axis and this is center. The circle is centered at the origin. Then this is called Cartesian coordinate system. And if there is a radius moves in angular manner and it makes 90 degree, then 180 degree, then 270 and 360 degree. Then this is typically called the polar coordinate system. Now we have hybrid model, x-axis, y-axis, radius, and it is moving with the angle. Anyway, I can divide this circle into polar coordinate in a way that angle is 0 to 360 degree. Consider the circle is made because angle goes from 0 to 360 degree. We have given example that it is not required that angle will always be 360 degree to make a circle, like r equal to cos theta. Take a equation in the polar coordinate system, r equal to cos theta. This also makes a circle, but in that fashion angle goes from 0 to pi, then it makes one half of the circle, and then pi to 2 pi means radius will become negative and radius will start from here and it makes full circle. In 180 degree of theta there will be full circle. Amazing, mind blowing, where radius is function over angle. Anyway, if I have to find the area of the circle, then this radius starts from here and then it rotates like this and in angular fashion, and then full it rotates and it makes the full circle. Consider that it goes like this. First section, from here, second section. I divide this theta angle in different sections. Now this is x-axis, this is theta. First section, second section, third section, fourth section. Means I divided this circle varying theta into n section. Consider this n section is all section has angle same. In that fashion, the first section angle is delta theta 1, delta theta 2, delta theta 3, delta theta I, and finally delta theta n. If I consider that circle is made with 360 degree, then delta theta 1 plus delta theta 2 plus delta theta n equal to 360 degree. This is how we divide the circle. The concept is that how I can find the area. Consider the AF section. If this is the first section, consider this is the first section, this is second section, and this is the third section, and this is the ith section. If this is ith section, if this is the ith section, then what is the area of ith section? Now I can sum it for all the I. Summation I equal to 1 to n because I divided into n part. AI, area of the ith section. Area of the ith section, if I say like this and add for all I get the full area. Means I'm trying to say that the area, if this is the first section, this is second section, this is third section. In that manner, if I see section by section, and then the net area is A1, the area of first section, A and subscript 1, A1 plus A2 plus A3, AN. That is the net area of the circle. Ith section area is AI. What is AI? One fundamental we saw that AI is 1 by 2 r square delta theta I, where delta theta I is angle in between it. If this is the I, if this is x-axis, then consider it makes theta degree with the x-axis, and this is the ith section. If this is ith section, then angle between this ith section from beginning to end is delta theta I. If this is radius and this is radius and radius is constant, then area underneath it, and considering this arc as a straight line, then the area underneath is 1 by 2 r into delta theta I. I mean 1 by 2 r into this arc. This arc is r into delta theta I is this r into r by 2. Means summation I equal to 1 to n 1 by 2 r square delta theta I, or 1 by 2 r into r delta theta I is the area of the ith section. If r is function over theta, then I can rewrite as summation I equal to 1 to n 1 by 2 function over theta whole square delta theta I. This is the summation that will give the net area, and this is typically it will fall in integral calculus because we are multiplying with delta theta I. Delta theta I is the gap between two radius. So delta theta I, if I sum for all, then it becomes net angle. So it is a fit case to convert into integral calculus. Integration of theta from 0 to the end 1 by 2 function over theta. If I consider radius is function over theta whole square d theta. If someone computes it, he will get the area of the circle. But here there are many assumptions. Please watch our previous video. Here are many assumptions unfortunately we made. If radius is function over theta, then if this is first radius, there is a high chance that next radius will be very small, because radius is changing if I move on. If this is delta theta I, this is r1, then this is r2, and they are not same. In that fashion, we estimated that arc that is passing, this arc length is r1 into delta theta I. This is the arc length, and this arc length is r1 delta theta I into r2 by 1 by 2. Means area of this section is 1 by 2 r2 into r1 delta theta I. That is 1 by 2 r1 r2 delta theta I. Okay, if I consider r1 r2 as function of theta, 1 by 2 function over theta whole square delta theta, means 1 by 2 function over theta whole square d theta, means lot of assumption we made. Can we calculate? Main concept is that calculation of the area through the repeated summation of every section. We divide the area into many parts. We started with the probability where we have many parts. Here also the area of the circle has many parts. If I add all the parts, it will give the summation. It will give the area. First we tried finding the area of the ith section through some approximation. There is another way, and that another way is that if this is the ith section, consider this is the ith section. If this is the ith section, I take any point here as an area point. A point can represent a line, a point on a line, a point on an area, a point inside a volume. Okay, if I say xyz, then someone would ask, what is xyz? Point on a line, point on an area, point in a volume. How it makes sense is, if I connect xyz from origin, then that is called position vector. This position vector can represent a line, position vector can represent a point on a line, or a point on an area, a point on a in a volume, or many things else. Consider there is a point here on an area called x comma y. Okay, now idea is, if it is x comma y, and consider that this is the first radius. Okay, if I move this first radius in a such a way, if I move this first radius in such a way, now if I move this radius, consider I move a radius 1 unit of angle. Okay, or if I move a radius to an extent that the change in radius, there is a change in radius, right? The radius is function over theta. If I move angle, the radius will decrease. Right now, consider radius is same. If I increase it, then radius will decrease, because radius is function over theta. R equal to cos theta. It will start decreasing. If I increase it, then how much change in radius I see in the ith section? This is ith section, where angle between it is delta xi, delta theta I. Now, if I move little bit from here x-axis, it is theta. If I move little bit here, consider the change in radius is delta r, and change in angle is delta theta. So the delta r into delta theta is equal to 1. Means 1 unit of area, 1 unit of area. If delta r and delta theta makes an area, consider there is a hypothetical plane where we have theta axis and r axis. This is theta axis, this is r axis. And in this plane, we have a point called theta comma r. Plus theta comma r, I move theta to some location, theta to another location. Makes sense? This is theta axis, and this is theta axis, and this is r axis. I have any point here called theta comma r. From theta comma r, I moved a little bit along the theta, and from theta comma r, I moved along the r. I moved at such an extent that now I have a third point here. This point, then movement, and this point, then this movement. If I add both movement, I have a third point here. It makes a small area. This area, consider I moved in theta in such a manner and moved in r in such a manner, this area is 1. This is what I'm talking. If I moved in such a manner that delta r into delta theta, whatever theta it moved and r it moved, if I multiply those delta, it becomes 1. If that is the case, then how much area, how much area it is spanned in x manner? In x manner. X point that represent a area point. It moves from one point to another point. Like x is moving from here to here, then I connect like this and it makes an area. Means 1 unit of area change in theta and r makes how many of unit change in xy plane? This is what we are talking. If that is the case, then if there is no full movement is there called delta theta, then delta r. In IS section, we have theta moves delta theta and r moves delta ri. If 1 unit of area change in theta r plane brings some unit of area change in xy plane, then delta theta I into delta theta r I, delta theta I into delta r I area change would bring how much area change? How much area change? I believe it is all right. If I say 1 unit of area change in theta and r brings some unit of area change in xy, if I multiply with delta theta and delta r with this area change, it will give what is the net area, what we see if there is a delta theta I change and delta r I change. Makes sense? Like what is 20 by 4? 20 by 4 is 5. What 20 is numerator and denominator is 5. 20, I'm sorry, numerator is 20 and denominator is 4. What is 20 by 4? 5. Means per unit change in denominator brings 5 change in numerator, 20 by 4. Now tell me that if denominator is 10, then how much is the numerator? Makes sense? Numerator changes 5 times the denominator is changing, 20 by 4. Okay, in that sense, now denominator change 10, then how much? So per unit denominator, numerator change 5 times. If denominator is 10, then numerator is 5 into 10, 50 it will change. Similarly, per unit change in theta and r brings some unit of area change in xy. Now, the theta and r change is delta theta I delta ri, then how much in area we see? This is what the area we are looking at is called ith section area. Ith section area is, now we have how much x changes. Okay, if I make 1 unit, now let's proceed in this fashion. Consider this is theta r plane and this is xy plane. This is theta axis and this is r axis. Now I have a point called theta comma r here, and then I make a change in theta and make change along r such a manner that whatever area is made is 1 unit of area. Similarly, with theta comma r, I have a point in xy plane called x comma y. There is a relationship. What is relationship? X equal to r cos theta and y equal to r sin theta. If I keep this relationship, then there will be a mapping of point theta comma r to a point in xy plane called x comma y, where x equal to gxy, g theta r, and y equal to h theta r, function over theta r, and x is function over theta r. Now, in that fashion, what we are trying to come now. Now, if I make 1 unit of change here, and 1 unit of change here, 1 unit of area change here, how many unit of area change I see here? Okay, in that fashion to calculate the main concept is here, actual concept to find here is, if I make delta theta unit change here and delta r unit change here, then delta theta delta r unit of change I see here. With this delta theta into delta r change here, how much I change I see in xy plane in the area here. That is the ith section area. Because because in ith section area, theta change delta theta I and r change from r1 to r2 delta ri. Okay, but these two are not the way we are seeing theta r and x and y. How much xy is changing? If xy is changing from one point to another point, in between area, that what it is forming. More or less, I want to say, I'm trying to understand for delta theta I delta r area, how much is the mapped area into xy plane? That is the area of the ith section. Okay, to find the area of the ith section, we take any point here at x comma y. Okay, now to find the area of in the xy plane. Now if this is theta comma r, if this is theta comma r, this point is x comma y. If I move here delta theta and delta r, if this is the area I am seeing that is newly formed because of delta theta and delta r, how much is the area you see in the xy plane? It is formed because of that. So if it is theta comma r, there is x comma y. If this is theta plus delta theta, then here it is x comma y to new point here. If it is up theta comma r plus delta r, then here from here there is another point here. Okay, if here area is delta theta comma delta theta into delta r, how much is the area here? To find the area, it may not be a rectangle. It may be parallelogram or something else. In that fashion, this x comma y and new point, if I denote it as a vector, and this x comma y and this point, if I denote it as a vector, if I take cross product of these two vectors, I get this area. Okay, means delta theta r into delta r area change in the theta r plane brings, if I say this is point P and this is P1 and this is P and this is P2, then P1 P vector cross P2 P vector cross product of this will give the area here. Okay, if I'm saying in that fashion, okay, what is the net area here? Okay, what is P1 minus what is P1P vector and what is P2P vector? Okay, P1P vector, P2P vector. Okay, this vector, if I do cross product, I get the area. If I divide that area, if I divide that area by delta theta delta r, I'll get change in the area in xy plane per unit change in the theta r plane. If I say I have 20 by 4, means if there is 4 in another plane and 20 in another plane with 4, I have 20 there. If I divide, I will get 5. Means per unit change here brings 5 change there. If I do cross product of P1P and P2P, I get the area in xy plane because of delta theta delta r. If I divide it, I get area change in xy plane per unit area change in the theta r plane. If I multiply it back with the delta theta delta r, delta theta I into delta theta ri, I'm sorry, delta theta I, ith section, delta ri, then I'll get the area. That is area change first I get, then into delta theta I, delta ri, I get the area of the ith section. Okay, someone can try it. What is P1 minus P? P1, if I denote what is P1 P vector? If this is G, if this point is G theta comma r s theta comma r, then another point is G theta plus delta theta comma r s theta plus delta theta comma r. If this is G theta comma r s theta comma r, then this point is G theta comma r plus delta r s theta comma r plus delta r. If I do take the cross product of these two, then it will become G theta plus delta theta comma r comma s theta plus delta theta comma r minus, because subtracting these 2 points will give the vector, minus G theta comma r s theta comma r. Okay, cross product. Another one, G theta comma r plus delta r s theta comma r plus delta r minus G theta comma r. Okay, divide by delta theta delta r, because we proceeded delta theta and delta r. Okay, that will give the change in the area in xy plane per unit change in the area in theta r plane. If I multiply with the delta theta and delta ri, then I'll get the area of this section, that is the ith section. Then I can sum it I equal to 1 to n. It will come as the P1 P vector cross P2 P vector by delta theta delta r. Then first numerator will come as G theta plus delta theta comma r minus G theta comma r by delta theta. by delta theta. I'm sorry. Okay, the P1 vector cross P1 P vector cross P2 P vector divided by delta theta delta r. I can rewrite theta delta theta. I can keep left side, delta r I can keep right side. It will become now uh, it will become P1 P vector by delta theta cross P2 P vector by delta r. What is P1 P vector? That is G theta plus delta theta comma r r comma h theta plus delta theta comma r minus g theta comma r s theta comma r by delta theta. This is exactly as the first principle differentiation, that is dgh by d theta. What is dg by d theta? Through first principle, it is g theta plus delta theta comma r s theta plus delta theta comma r minus g theta comma r s theta comma r by delta theta. Means this is dgh, this is dgh g comma h, or d of gi plus hj. If I talk in vector form, then I vector and j vector, gi vector plus hj vector. G is x and h is y. D of xi plus yj, or d of p, this point, d of p by d theta cross d of p by dr. Whatever comes, it will come as a vector. Its magnitude into its magnitude, that is the actual change in area I see with the change in 1 unit of area in delta theta delta r. Dp by d theta cross dp by dr, and then magnitude, and then delta theta I delta theta delta ri. Now summation sign I equal to 1 to n, because I divided the circle into n parts. This is the area of the ith part. Summation I equal to 1 to n, I equal to 1 to n. Okay, magnitude, or the absolute value of cross product of two vectors. One is dp by d theta cross one is dp by dr. Okay, magnitude into delta theta I delta ri. If I add it, then we will get the area of the circle. Now this is a fit case. This can be considered as f theta r. If I see the modulus, the magnitude I have taken dp by d theta cross dp by dr, its magnitude, it will come as a theta r. It will consider as a function over theta r. Function over theta r into delta theta I delta ri. Okay, this will be considered as a kind of summation I equal to 1 to n. Means this is repeated addition of delta theta. This will be considered as function, and where this area is delta. We are bringing discussion as a multivariable repeated summation, two variable repeated summation. This is example of two variable repeated summation. We will proceed on this. So till now it is summation I equal to 1 to n, and then modulus dp by d theta cross dp by dr, magnitude delta theta I delta ri. Now this is a kind of analogous to, I have a theta r plane, and theta r plane I have a theta axis and r axis. Theta axis I chopped into n part, and r axis I chopped into n part. In that way, I have now rectangular region section, and that is n by n, an array of n by n, where each section is a width of delta theta I and delta ri. Make sense? One area width is delta theta I into delta ri. Make sense? And for this area, width, we have a bar chart. We talked about bar chart. This is x-axis. Then we have bar chart. Okay, each section. Now we have, instead of x-axis, we have theta r plane, and then now this is dual in the sense that instead of chopping n times on axis, we have chopped two multivariate on theta axis and r axis. We have chopped n times. Now each section here is delta theta I and delta ri of width, ith section. Now there, if I draw a bar, makes sense? Here we drew a bar, like dice I was throwing, I had a bar. If If I cut a stick, then I had a bar of height 1 by n. Here, in each section of delta theta delta r, width and length, there is a bar now, and bar is of height that I can say function over theta and r. That bar height is dp by d theta cross dp by dr magnitude. So I can rewrite it as a function over theta and r, delta theta I, delta ri, summation I equal to 1 to n. This is a fit case to come to integral calculus. Please watch our 3 to 4 videos, very serious, or 5 videos, very serious, date wise. There we have described in a way that is a pseudo calculus problem. So what is the how summation we can bring into integral calculus? If I have discrete bars and gap between each bar is delta, and I am multiplying bar height with the delta and then I sum it, then it will give the area of a particular section. Here it is giving volume of a particular section. If I constitute a height and area, it will give a volume in theta and r plane. If I multiply height with the area in theta, it will give volume. Means volume I have chopped it into many sections. Okay, in that fashion, volume, the height into the section area. If I take, then one section volume we are taking. If I do fx dx or f theta r, we have taken as dp by d theta cross dp by dr magnitude as function over theta and r, f theta r. If I multiply this f theta r, the height, with the whatever gap, it is giving the volume of a particular section. If I add all the volume of all the section, it gives me the full volume. Full volume is nothing but f theta r d theta dr. F theta r is the height into d theta dr is a theta r plane. If I integrate f theta r with d theta dr or d theta r plane, it gives the volume. This volume I have subdivided into many sub-volumes, and each volume has a width of delta theta I, delta ri, and height as f theta r. And then if I add, this is a fit case to come as integral calculus. What is not fit case as to come to integral calculus? If I say summation I equal to 1 to n and then dp by d theta cross dp by dr magnitude, that's it. Other side I am not talking. Delta theta I into delta ri. If I do so, the way first example we had taken, or next stick example, if I divide into n part and if I add all the bar, can it be same as integral calculus? No, it will not be same. You have to multiply with the gap. You have to add the sectional area to get the full area, and full area is the integral calculus. Here you have to add all the sectional volume to get the full volume, and full volume is integral calculus. But here it is. We have width delta theta delta ri and then height into width and height into delta area. If I multiply for a particular section and if I add it, then we are adding all the sub volume to have bigger volume, and bigger volume is nothing but integral calculus. So this is a fit case to become integral calculus. What is your integral calculus? Integral calculus is the limit of theta and r plane. Now, if I talk in theta and r plane, what is the limit in theta and r plane? That limit dp by d theta cross dp by dr magnitude d theta dr. This will be the integral calculus that comes from the sum of that has come from the repeated summation in 3 dimensions. Okay, we will proceed in solving this. Okay, then we'll see other things. These are not available in any of the book. That how repeated summation we can take in 3 dimensions and then we can bring into integral calculus. The way, see how we are summing up, but at the end we are getting the area of a circle only. But this is how it is. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number. dp by d theta, p is xi plus yj, x is r cos theta, y is r sin theta, dp by d theta, dp by dr. Make sure that when you say dp by d theta, r is constant. Why it is constant? This is theta r plane, this is xy plane. In theta r plane, I move along theta, theta to delta theta, theta to theta plus delta theta. R is constant when I move like this. Here, theta comma r plus delta r, theta is constant. In that fashion, this area mapped here as P1 P vector cross P2 P vector. In P1 P vector, r is constant and P2 P vector, theta is constant. And then dp by d theta, r is constant. Makes sense? Because this part became dp by d theta. This part became dp by dr. Theta is constant. Then we will solve it. Okay, anyone can solve it. Please do not mind supporting us. +91 in India country code 94831606110. This is not available in any of the book. Anyone can try.